In Chapter 17, we're going to look at all the different components of the digestive system and how those interact and work. The function of the digestive system is to ingest food, propel food, and then mechanically and chemically break that food down, absorb nutrients, ingest them, absorb them, and use them, and then defecate the remainder, the things that we do not need, all right, the waste material. So digestion is defined as the mechanical and chemical breakdown of food into a form that the cells can use. We absorb this and assimilate it, all right? We put it to work. The organs of the digestive system carry out these processes, those also along with ingestion, propulsion, defecation, absorption. And it consists of the alimentary canal, which we'll look at in the next slide. It extends from the mouth all the way to the anus and includes the accessory organs that empty into the alimentary canal. So here is the alimentary canal, and in class I will often draw this out on the board and we will diagram this out and we will list all the steps of digestion, including the enzymes and where 3 of the 4 macronutrients are digested, all right? And so that is typically an essay question. So let's look over here. We've got the alimentary canal on the right and the accessory organs here on the left, okay? And I kind of circled above the word, but you get the point. Those are the accessory organs. So let's start with the actual alimentary canal. And that's going to start with your mouth. And your mouth is where we have chemical breakdown of food. You chew and you undergo what is called mastication. You break it physically down. So that is mechanical digestion. And then we also have the very beginning of chemical digestion for carbohydrates because we have salivary amylase in there. All right, and I'm going to get a little too far into detail if I keep doing that. So I don't want to go through all the details yet. So the mouth. And then extending from the mouth, we have the pharynx, which connects the mouth to the esophagus, and then on, of course, down through the esophagus, and we actually have some peristalsis going on there, which empties into the stomach here. And the stomach is where a lot of digestion occurs, and then it leaves the stomach and goes into the small intestines here. From the small intestines, we're going to enter the large intestine, and where we're going to go through the large intestine, go to the rectum, and then be expelled out through the anus. All right, so those are the main organs of the alimentary canal. You need to be sure that you know these and what their function is and what type of digestion they do. So we're going to look at that. The accessory organs, there are 4 accessory organs. The first of those are the salivary glands. We have 3 of those, and those begin or initiate the breakdown of carbohydrates, among other things. Then we have the liver, the gallbladder, and the pancreas. And so those are kind of extra organs that secrete substances into the alimentary canal that help us with digestion. If you stretched it all out, the alimentary canal would actually be about 8 meters long, all right, which is pretty long, all right. You can see most of that is going to be the small intestines here, some of the large intestines, but the small intestines is very long. So the wall of the alimentary canal has 4 layers: mucosa, submucosa, which is where the lymph arteries reside, the muscle layers, and the serosa, which is the GI tract area. And so the sequence for the layers in the walls of the alimentary canal from the innermost to outermost: submucosa, mucosa, submucosa below, muscles, and serosa. So it's important to remember those 4 layers. You need to know these 4 layers. So mucosa, mucus is protective in nature, right? It traps things, but is that the only thing that it does? Why would you have mucus in your stomach? Think about that for a minute. Why would you need mucus in your stomach? Well, what else do you have in your stomach? Hydrochloric acid, right? You have stomach acid. Stomach acid would eat away your skin if you didn't have that mucosa or the mucus layer there protecting it. So it's got a protective function, a secretion function, and it even helps some with absorption. Below that, you have the mucosa, and this is to help provide nutrients and transport and absorb nutrients. Okay, so it brings nutrients to the tissues and then it takes those absorbed nutrients and materials and brings them back to where they go. Not all of them, but a lot of them. Under that, of course, we've got to have some muscles. We have this action called peristalsis and segmentation that helps move things along, and you can't do that unless you have muscles. We have smooth muscle fibers in circular grooves and longitudinal, okay, and so that helps move things along in the tube. Then lastly, we have serosa, which is the epithelium, and that is there for a protection and some lubrication. All right, so I talked about movements. I talked about segmentation and peristalsis. So let's look at what that is. We have movements. We've got to have a way for this food to move through our alimentary canal. If it's 8 meters long, how is it getting through all of these 8 meters, right? So we have mixing movements, and that's segmentation, and then we have propelling movements, that's peristalsis. So mixing is going to be like churning. It's done by smooth muscles. There's rhythmic moving of small sections, and we're seeing that, oh, I set my pen down somewhere. We're seeing that in this top section here, all right? And then so segmentation aids mixing. It aids that by contracting and relaxing those smooth muscles and mixes those contents of the stomach up. Peristalsis is those wave-like contractions, those wave-like movements along the tissues, pushing it along, and so they move kind of like dominoes falling. They move in order together in a coordinated fashion. So one will squeeze, and then the next, and then the next, and so it pushes things along, forward along in the canal. So how does the nervous system innervate or react with, so to speak, the alimentary canal or tube? So we have branches of both sympathetic and parasympathetic divisions of the autonomic nervous system that extensively innervate the alimentary canal. So autonomic, remember, is the automatic division. So these things occur, of course, without conscious control. Now, many of the fibers come together and form a network, or what we call a nerve plexus. So we have a submucosal plexus, which controls the secretions of the gastrointestinal tract. Then we have the myenteric plexus, which helps control gastrointestinal motility. Sympathetic imposes those, remember, of the parasympathetic. And so, for example, mixing and propelling movements may be stimulated by the parasympathetic, but yet inhibited by sympathetic divisions. These are also associated with maintenance of things like muscle tone, regulation of strength, rate, and velocity of muscular contractions. Now, when I say muscle tone, this is not in the regular connotation of the word tone, muscle tone, like we think of, oh, they're toned, they're buff. When we say muscle tone, that's kind of like a constant, I don't want to say constant contraction, but a constant state of being. Like, for instance, in order for your body to be held upright, you must have a certain amount of muscle tone to the muscles in your back. All right, and so parasympathetic impulses increase activities of the digestive system, where sympathetic inhibit or decrease digestive actions. So let's look at the individual organs of the alimentary canal, of the digestive system. So the first and most obvious is the mouth, right? So we have the mouth, which can be called the oral cavity or the buccal cavity. I always say buccal, but it is technically buccal. So this is the first portion of the alimentary canal, and the function is mastication. You need to know the function of each portion of the alimentary canal. You need to know the canal in order and know the function there and what type of digestion occurs there, and if there are any enzymes, what enzymes occur there. Okay, so you need to know all of this material here I'm telling you. So the function is mastication. Mastication is, of course, chewing, mechanically breaking up solid particles. It is to ingest the food, and we do mix them with saliva. Of course, the mouth does function as an organ of speech, and it is does function with some sensory reception, like our taste buds, which we really appreciate and enjoy. And it is surrounded by the lips, cheeks, tongue, and palate. And so this includes the oral cavity, which is the opening on the inside, and the vestibule, cheeks, which form the lateral walls of the mouth, and then the lips. And those are very mobile structures, of course, that surround the opening of the mouth. So the enzyme here would be salivary amylase. Salivary amylase actually begins the breakdown of carbohydrates chemically. So main function is mechanical with a tiny bit of chemical. All right, so next we have the tongue. This is a thick muscular organ that occupies the floor of the mouth, and it nearly fills up the oral cavity there, at least on the, sorry, I've got a dog underneath me, inferior portion here, okay, when your mouth is closed. It also contains the lingual frenulum. That is probably a strange word you may not have ever heard before. Lingual frenulum. I can't even say it correctly right now. So lingual always refers to lingua, or speech. Lingua. That's where we get linguistics from. And so this is actually this little flap of skin right there. That is the lingual frenulum, and that holds your tongue in place. If that is too short, you can be what we call tongue-tied, and they actually have to go in and clip that. I actually have a friend that just had that done. Actually, it's not a former student, but more my kid's age. But anyway, so yes, that can be a problem for infants as well. If they are not able to latch on, it is often due to the fact that that lingual frenulum is too short, and so they go in and clip it. And then we also have the papillae, which are the raised projections here on the tongue. Right, lingual papillae, and this is where the taste bud resides. And then you have the lingual tonsils. Now these aren't your tonsils that you get removed. These are the lingual tonsils. So the body of the tongue is skeletal muscle. It's got fibers running in several directions, and that helps us move food underneath the teeth. So we can move the food from side to side, up and down. We can stick our tongue out, all of those things. Papillae are rough projections, okay? And they provide friction as well as housing those taste buds. And then the lingual tonsils are actually lymphatic tissue covering the back of the tongue. And then the tongue is anchored to the hyoid bone at the back. And remember, the hyoid bone is the only freely floating bone in the body. I say freely floating figuratively. Next, we have the palate. We have the hard palate and the soft palate that forms the roof of our mouth. So the palate forms the roof of the mouth, or the oral cavity, has the hard anterior portion and the soft posterior portion. We have the uvula, okay, and so we have the uvula right here. And so be careful with these structures. I see this confused a lot. Here's the hard palate here, okay? And then this portion above the uvula is the soft palate, all right? And so notice the uvula is almost parallel there to the opening of the mouth, if that will help you in the diagram to be able to distinguish these when you label these. All right, so the uvula hangs down, and its function is to close the opening between the nasal cavity and the pharynx. That keeps food out of your nasal cavity during swallowing, which is a good thing. I mean, if you've ever had projectile vomiting, or when you were a kid where it comes out of your nose, and I know that's gross, but most of us are medical students, right? So yeah, it's not a pleasant thing. All right, so we want that to remain closed. All right, so next we have palatine tonsils, and that's what we think of as our tonsils, and you can see these. Let me erase some of this here. These palatine tonsils are located right there, just below, not completely, but kind of below, more towards the back of the throat of the uvula there, all right? So those are what we think of as our tonsils, and these are also lymphatic tissue, and they have an immune function, all right? We tend to think that they're useless, but they're really not. They do serve a purpose in immunity. Then we have our pharyngeal tonsils, and these are what we typically call our adenoids, okay, our adenoids. If I asked you what system teeth belonged to, most people are going to say the skeletal system. but that's not right. They're not bone. They're not bone at all. They're not part of the skeletal system. These actually contain two different types of proteins that are not found in bone, and they are structurally different than bone. So these are not part of the skeletal system. Teeth are the hardest structures, however, in the body. Their function is to break food into smaller pieces and start that mechanical digestion. Chewing actually increases surface area for enzymes to act on. That's important. We have 20 primary teeth, which are what we call deciduous teeth, okay? And we have deciduous trees. They lose their leaves every year. And so deciduous teeth are the ones that we lose. And then those are replaced by our secondary or permanent teeth. And then we will have 32 of those, all right, normally. So we have different types of teeth that have different functions. We have incisors, and these are best adapted for biting off chunks of food. Then we have our canines, which grasp and tear the food. And then we have our premolars and molars, which help to grind the food. All right, and you can see those over in the picture. You're probably kind of familiar with some of that, but these are the incisors here. If you remember, that's going to be near things like the incisive foramen. And then these are your canines, which give you the more tearing effect, and those are cuspids. And then the premolars are bicuspids, so they have two cusps. And then, of course, you have your molars, and these include your wisdom teeth if you have them still intact. Alright, so this is one of those portions in lecture where I tend to see students, feeling their teeth. They're grossing out a little bit. Bacteria. What are dental caries, and why is it important to brush your teeth? Does sugar really cause your teeth to rot? Well, let's look at this. So bacteria cause dental caries. Dental carie basically is a cavity, okay? Or what causes a cavity. And they do that because they metabolize carbohydrates in food. So there is a hint to one of the answers to the question I asked you. What is a carbohydrate? Well, it's sugar. So sugar feeds bacteria, okay? So they metabolize carbohydrates in food, and then they produce an acidic byproduct that actually damages the enamel on your teeth and the dentin. Enamel is that outer layer surface of your teeth that really protects them, and then if you lose your enamel, your teeth just really start to rot really badly. All right, dental caries, they're cavities. They can become plaque, dental plaque, which is what they scrape off when you go and get a dental cleaning, especially a deep cleaning. If you're an older adult, you probably had some of these. This dental plaque is actually a biofilm, and a biofilm is a big community of bacteria that live and work together as one. All right, and so they're basically a commune of bacteria. And this is protective for the bacteria because it makes it to where we can't reach all of the bacteria. And so you have to get in there and floss and break up those caries, break up those biofilms in order to be able to fight the bacteria. And that's also another reason why it's important to get your teeth clean. And these are some particular bacteria that like to reside on your teeth: Actinomyces, Streptococcus mutans, and Lactobacillus. All right. They have interestingly been doing studies of dental plaque biofilm from ancient civilizations, from people, to study and see what types of food they were eating and all these crazy things that you wouldn't think they would be able to get off of somebody that's been dead for hundreds of years. So it's really kind of an interesting thing, but it also makes you want to go home and brush and floss your teeth. This chart is in your textbook here, 17.3. The chapter numbers may be a little different. This might be out of the newer edition, but in our chapter for digestion, I think it actually is 17. The reason I included it, though, is because, as I told you earlier, I want you to know all the parts. You need to know their location, obviously, for lab, but you need to know the function. And so this is a really good summary here for you to study and make flashcards from. So that's a hint. All right, we're going to look at salivary glands. We have 3 pair of salivary glands. So pair means they're bilateral. They're on both sides, right? We have parotid, submandibular, submandibular and sublingual. Remember, sub means below. Okay, and we're going to look at the locations of these in another slide or two. So salivary glands, the purpose is to secrete saliva. Makes sense, right? Saliva helps to dissolve food so that it can be tasted. It has enzymes, as I have already said, salivary amylase, and that begins the chemical digestion. I'm looking for a color that's going to show up here. Chemical digestion of carbohydrates. You need to know that occurs in the mouth. All right, and that is due to salivary amylase. I don't think I can write that on there neatly, but let's try. Salivary A-R-Y amylase. That may actually be on a slide somewhere, but I do a lot of this on the board in the regular classroom settings, so I just want to make sure you have that word. If you can read my writing there, salivary amylase, okay? Now let's erase that so we have room if we have to write or draw something else. All right, so that does chemical digestion. The parotid glands are some of the largest, or actually are the largest of the salivary glands. The salivary glands moisten food, binds them together, and helps to create what we call a bolus of food, because we're going to make a little ball of food as it goes down through our alimentary canal. Okay. There are many minor glands as well that are scattered and located throughout things like your tongue and your cheeks. But these are the three important ones. Okay. We also have bicarbonate ions that are in saliva, and that is a buffer, and it helps to buffer and regulate the acid in the mouth, keeping the pH near neutral where it needs to be. All right. So the different salivary glands are made up a little bit different. They have a different proportion or ratio of secretory cells, serous cells, and mucus cells. Of course, structure determines function. Serous cells produce a watery fluid and that have that digestive enzyme that I told you about, salivary amylase. So there's a much easier way to read it right there. And that breaks down starch into disaccharides. So that begins the chemical breakdown of carbohydrates. And then we have mucus cells, which secrete mucus. Of course, those serve to trap foreign invaders coming in. All right, so the pharynx and the esophagus. The pharynx connects the nasal and the oral cavities with the larynx and the esophagus. The esophagus is divided into three components: the nasopharynx, the oropharynx, and the laryngopharynx. The nasopharynx is superior to the soft palate. It can be seen right here. So nasopharynx on the top, so N-O-L. All right, and then you have the oropharynx, which is right here, and then we have the laryngopharynx, and that is the order they come in. Swallowing is actually more complex than you might think. It has three different stages. We first have the voluntary stage. We have saliva mixing with our chewed food, and it forms that bolus of food. So we're going to call the mix of food a bolus until we get to the portion where we're going to call it chyme. All right. And so the second stage here of swallowing begins as food reaches the oropharynx, stimulates sensory receptors around the pharyngeal opening. This triggers the swallowing reflex. All right. This includes the following actions. The soft palate, including the uvula, is going to raise. That prevents food from entering the nasal cavity. We already talked about how bad that is, right? The hyoid bone and the larynx are then elevated. The flap-like structure attached to the larynx, called the epiglottis, is going to close off the top of the trachea so that food is less likely to enter the trachea. The tongue is then going to be pressed against the soft palate and the uvula and seals off the oral cavity from the nasal cavity. Longitudinal muscles in the pharyngeal wall will contract, pulling that pharynx upward towards the food. Okay, so it's going to pull that up towards the food. Then the lower portion of constrictor muscles relax, which opens the esophagus. The superior constrictor muscles will contract, and that stimulates a wave of contraction, that peristalsis, in other pharyngeal muscles. And this wave forces the food down into the esophagus. The swallowing reflex momentarily inhibits or stops breathing. Of course, you don't want to inhale the food that you're eating. So then during the third stage of swallowing, peristalsis transports the food in the esophagus on down through the stomach. And again, we have some peristalsis that occurs there. So the bolus of food then in the esophagus is going to keep moving forward. The esophagus itself is going to pass through an opening in the diaphragm we call the esophageal hiatus, and that is important, the esophageal hiatus. You need to know the location of that. You know, hiatus is when we take a break, so this is a break in the diaphragm, okay? This allows the passage of food to go through there. If you have something like a hiatal hernia, this is where part of the stomach actually protrudes through the diaphragm because of a weakness in the tissue. And then it causes that esophageal hiatus. That will cause things like heartburn. It can actually cause ulceration of the esophagus, loss of blood. It can be a predisposing factor even for cancer because it damages the cells. And sometimes that can even also, the heartburn and the ulceration can cause asthma, can trigger asthma attacks in people that are sensitive to that. All right. We do have those mucus glands there in the submucosa, and we have the lower esophageal sphincter that surrounds the lower end. There's going to be 3 sphincters that I want you to pay attention to because these are circular muscles that control movement through a certain area. And so we're going to look at 3 of those. This is the first one, the lower esophageal sphincter.